away from the rocket on the pad. Right outside on the lawn, the crowd is starting to gather, and after liftoff, we expect that crowd to head back in to watch the rest of the launch with us and have a party.
And right behind us are 3 generations of Raptor engines, the third of which we're looking to debut on the next generation of Starship. And we'll talk a little bit more about that upgraded rocket later in the program.
Yeah, and if you watched Flight 10, you'll know it was a really, really good day for Starship. All objectives were met, and we got tons of great data to learn from. And today, we're looking to build on the success of that flight.
Yeah, that's right. Like in Flight 10, we're again planning to deploy Starlink simulator satellites as well as test the limits of ship's heat shield during re-entry. A controlled descent, flip maneuver, and soft splash in the Indian Ocean are also planned for ship. And hopefully, our recovery team will be able to deliver some more of those amazing views that we got back on Flight 10.
Yeah, those views are just awesome. Another crazy thing, and for those of you keeping track, today actually marks the 1-year anniversary. Is guaranteed.
All right.
And Dan Hewitt joins us from over near Mission Control. Dan, how are things looking for launch today?
Hey, Jake. Hey, Amanda. Hey, everybody. We are looking great. I'm Dan Hewitt with SpaceX Communications. That's right. Right behind me is our Launch Control Center here at Starbase. Flight control team is on there. They're getting Starship and Super Heavy ready for liftoff. So as you can tell, when we look at the vehicle, prop load is underway. Things are looking good. We did shift our T0 a little bit. We're tracking to 6:23 p.m. Central Time, just a couple minutes into our window. All right, so as we noted, back in August, Flight 10, it did all the things. Did all the things we wanted it to do. Started off with Super Heavy, those 33 Raptor engines igniting, lifting off right at the top of its window at 6:30 p.m. Central Time. It was able to do a successful ascent, followed that up with hot staging, Starship's upper stage igniting those 6 Raptor engines, separating Super Heavy, making its way back down. We saw the hot stage pop off. It then completed its boost back burn, put it on the course towards that splashdown zone. It successfully did that landing burn when we intentionally disabled one of those 3 center engines. During the final phase of that, used a backup engine, entered into its final hover, shut down the engines, and then splashed down into the water. Ship, meanwhile, completed full duration ascent burn, got to its planned velocity, successfully put it on that suborbital trajectory, and then it was on to the in-space stuff. That first in-space objective was completed. 8 of those Starlink simulators were deployed. That was the first successful payload demonstration we've ever had from Starship. Each of these simulators, similar in size to the V2 Starlinks that we're going to be launching next year to add significant capacity and capability to the network. Then it was on to our second ever in-space relight of a Raptor engine. That's a key capability for when we're going to do deorbit burns on future orbital missions, and then when we're doing deep space maneuvers. Then on to the critical reentry phase, we're able to get data on the performance of that heat shield, the ship structure, push the envelope on it, using the flaps, got it down to the splashdown zone, did the landing flip, did the landing burn. Killer views from the recovery team, soft splashdown over in the Indian Ocean. We were just about 3 meters off of our target, so pretty much nailed it. It was a huge day, tons of excitement here at Starbase. Just a reminder, though, this is still the early days. I mean, we're on Flight 11 today. There's a lot more we're going to do to get the full reusability, increase our launch cadence, eventually start sending missions to the Moon and Mars. I mean, we've got thousands of launches to come. But for now, we're looking good for launch. Toss it back down to Amanda and Jake.
Awesome. Thank you, Dan. Starship is the first orbital launch vehicle engineered to be fully reusable, just like a commercial airliner. In fact, to the end, we're actually reflying a Super Heavy booster for the second time today. This booster last flew on Flight 8. So let's just start with how powerful this rocket really is. When you stack Starship up against one of the world's biggest airplanes, the 747, a single Raptor engine is actually double the thrust of all 4 airplane engines put together. So that means the Super Heavy over on the pad right now, with its 33 Raptors, is equal to the power of about 64 747s.
Yeah, that's just crazy, Amanda. The power this rocket generates is incredible. To be specific, it's over 16.7 million pounds of thrust. Numbers almost incomprehensible, but it's just crazy. All right, to break it down, Starship is made of 2 parts. First is the Super Heavy booster, which is powered by 33 of those Raptor engines that run on liquid methane and liquid oxygen. And second is the Starship upper stage, powered by 6 Raptor engines. 3 are optimized for sea level performance, and 3 are for vacuum performance with that larger nozzle extension. All right, it's the Starship's second stage that will one day carry cargo, payloads, and people all the way to Mars and beyond.
The Super Heavy booster is designed to launch, separate, flip, and return to the launch site where it can be caught by the chopsticks on the launch tower. However, as previously noted, we won't be attempting one of those catches today. Starship, on the other hand, re-enters the Earth's atmosphere at the conclusion of its mission, steering itself to a vertical landing or catch. And both stages are designed to return to Earth and fly again, making this the first rocket in history that will be fully reusable.
Yeah, and we cannot forget that between the two vehicles is the hot stage ring, a structure made of steel that allows the ship's engines to ignite while still attached to the booster, enabling a faster and more efficient stage separation. Right now, that hot stage ring is single use, but in the future, it will be built in directly to the V3 booster forward end.
And finally, the infrastructure built to support Starship is referred to as Stage 0. This includes the launch pads, tank farm, and the launch towers, which hold the chopsticks that catch the Super Heavy booster and eventually will also catch the ship.
Yeah, and to get us ready for launch today, we recently conducted another static test fire, basically where we fire up the engines to mimic a launch without actually launching. You're seeing the booster on the screen right now. It's a crucial milestone to let us know we're ready to go. And then here we're seeing ship. We did this for the second time on a retrofitted mount on Pad 1. We had a full 9-second duration burn on all 6 engines.
We should also note that today's launch on Pad 1 is intended to be the last launch on this pad in this configuration. As we head into the next generation Starship flight test program, we'll be modifying Pad 1 to meet the demands of our future missions.
Yeah, and among many other things, we're installing a new orbital launch mount, a new flame trench system, and upgrading the chopsticks for future catches. So until that's complete, we'll be running operations from Pad 2, which will be coming online very soon. All right, let's go over to Hawthorne, where Tyler is ready to talk a little Starlink.
Thank you, Jake and Amanda. My name is Tyler Lionquist, and I'm a Starlink business analyst here at SpaceX. Starlink is SpaceX's low Earth orbit, high-speed internet that's bringing connectivity both on Earth and in space. So, Starship is outfitted again today with 4 Starlink terminals, powering those incredible live shots of ship in orbit, through re-entry, and then all the way down to splashdown in the Indian Ocean. Now, we've had a couple of recent milestones that are worth celebrating. Back in September, we launched Starlink for its 300th time, and this summer, we surpassed 7 million active customers with service available across 150 countries and territories. We've come a really long way since turning on service for our first paying customer in rural Idaho 5 years ago, back in October of 2020. And I'm happy to report that Wendy and Sean are still Starlink customers today. So in just over 5 years, we've added dedicated services for aviation, maritime, RVs, and rail, and have expanded our emergency response capabilities. We've activated high-quality internet for millions of people, including those that live in some of the most remote places on Earth. Starlink is enabling rural school districts, counties, and tribal governments to offer online access to education, telemedicine, and many other critical services, in some cases for the first time ever. And yet, a third of the planet continues to go without access to reliable high-speed internet, so there's a lot more work for us to do. But Starlink was designed from the very beginning to meet these needs. And as each new version of Starlink comes online, the constellation's capacity and performance increases significantly. The larger V3 satellites that will deploy from Starship will bring gigabit connectivity to users and are designed to add 60 terabits per second of downlink capacity to the Starlink network. That's more than 20 times the capacity added with every V2 mini launch on the Falcon 9. And then on the cellular front, last month, SpaceX announced a deal that provides Starlink with exclusive spectrum for its next-generation direct-to-cell satellites, which will be capable of providing broadband service to cell phones globally. Starlink is the largest 4G coverage provider on Earth. Over 7 million people across 5 continents already rely on Starlink to connect their LTE phones to data, voice, video, and messaging, where terrestrial service is unavailable. So we're excited to have the opportunity to help close those coverage gaps and ultimately eliminate mobile dead zones around the world. So yeah, there's a lot happening with Starlink, and there's a lot more to come. So let's head back to Amanda and Jake at Starbase to take us through today's flight profile.
Thank you so much, Tyler. So today's float profile, we're looking to get our second re-entry with this iteration of ship. And prior to every launch, we work closely with the FAA and international air traffic organizations to efficiently and safely integrate launch and re-entry operations into the airspace.
And we've got a special guest here.
What the?
We're live.
What's up, guys?
How's it going? Good to see you, boss.
Hi.
Hey. How's webcam?
Good. We're live right now.
What the?
Yeah. Getting ready for Flight
Come say
11.
hi.
How are you feeling for it?
Good. This is the first time that I'm going to be actually outside standing and watching the rocket. Because normally I'm in mission control and stuff.
Okay. Yeah.
But now I'll be standing out in the garden there.
Okay.
So
Awesome.
it's really going to be much more visceral.
Yeah. You're gonna feel
Great
it.
place
It's
to
gonna be.
watch.
It's gonna be.
Have
It's
you
gonna
been
be
out there
awesome.
when it's filtering?
We'll be in here this time, but usually we're out there watching. Yeah.
All right, sounds good. All
Good
right,
luck
Later.
and have fun.
Have fun.
All right, so that was an exciting cameo there. But yeah, starting with liftoff, we'll get into the flight profile here. Super Heavy will ignite 33 engines, 24 of which are flight proven today. We'll power through Ascent ahead of hot stage separation, where booster will shut down all but 3 engines. Stage 2 lights its Raptor engines while still attached to Super Heavy. That is what we call hot stage separation. We'll see a directional booster flip and engine relight for boost back. And we'll be intentionally headed to a splashdown in the Gulf with a V3 style landing burn demonstration today.
Meanwhile, ship will continue with its ascent burn to a suborbital trajectory, where it will attempt to deploy 8 Starlink simulator satellites. And we're also planning to relight a single Raptor engine. Then it's time for a re-entry, where we're once again testing the limits of Starship's heat shield by intentionally removing tiles. The ship will also perform a pretty dynamic banking maneuver that mimics the path of a return to launch site for Ketch that will fly on a future mission. And if all that goes as planned, we'll conclude the test with a landing flip, burn, and soft water splashdown in the Indian Ocean. So definitely another action-packed flight profile, Dan.
This is planned to be the final launch of this version of Starship, version number 2. Right now, we're actively building multiple next-generation V3 Starship and Super Heavy vehicles in the factory, kind of right behind us, so let's take a minute and nerd out a little bit. All right. Those are going to be launching from Pad 2, which is nearing completion down here at Starbase. Both the pad and the vehicles are going to roll in really significant changes. This is building on everything we've learned from all of these flight tests to make a vehicle that we're looking to mass produce. Starting with the Starship upper stage, which is going to look pretty similar on the outside, but it's getting pretty much a complete overhaul under the hood. We're getting major design changes to its propulsion system that's going to accommodate that new version of Raptor, which puts out higher thrust. We're also getting an energy storage upgrades, tons of avionics changes, a lot of things that will enable longer duration missions. One notable thing you'll start seeing on the outside are these new docking adapters, which we'll use when we bring 2 starships together for propellant transfer. That's a core capability of Starship that we're going to demonstrate next year. Bottom line, though, this is the Starship we're planning to use for all of our next major milestones: orbital missions, return to launch site and catch, reuse, propellant transfer, and then making our way to the moon and Mars. Now, Super Heavy, we've shown some of this off, some of this hardware already coming out of the factory. It has upgrades like this, a redesigned fuel transfer tube. That thing's roughly the same size as the first stage of a Falcon 9 rocket. That channels all that cryogenic fuel down to Super Heavy's 33 engines. We made it bigger. It's basically a rocket inside of our rocket that gives us a faster, more reliable flip and simultaneous engine startup. New booster also going to have an integrated hot stage, a lot more vent area, and it's designed to be fully reusable. Pressure from those engine plumes gets vented out, mostly offset just by the pressure in the fuel tank. That is the top of the fuel tank. And then we add a non-structural layer of steel on the top that helps take all the heating. It's mapped to where all the high heating goes. Grid fins also getting a big change, going from 4 down to 3. They're 50% larger though, much higher strength. They're also going to get used for vehicle lift and catch. That's all made possible. There's a new catch point addition on those grid fins. We've also kind of reclocked their position on the booster. That aligns them with the catch arms. Yeah, we got it right in the middle there. All right, and then powering it all, Raptor 3. Looks radically different, just straight up radical. Tons of major changes. It's coming in higher thrust, dramatic reduction in parts, tons of control mechanisms moved inside. Our McGregor team's built some additional stands like this one, which essentially is the bottom of a super heavy booster. Lets us do gimbal or steering tests. So that's been really exciting to see. We've also been getting vacuum versions of Raptor 3 into test. The first flight engines are already in production and are about to start acceptance testing for Flight 12. So a lot of exciting changes coming, and we're getting ready to mass produce everything, including one of the really key contributors to that rapid reusability, the heat shield tiles. Let's jump over to Tyler real quick in Hawthorne, who's got a really cool look at what's happening with tiles in Florida.
Thank you, Dan. Indeed, Starship's heat shield is the linchpin to full and rapid reusability. We can't launch, land, refuel, and launch again if we have to spend months refurbishing the heat shield after every launch, like they did in the Space Shuttle program. So, in a future where Starship is flying several times a day, many, many thousands of heat shield tiles will be required. So yeah, we need to get cooking on those tiles, which is exactly what's happening inside the fully automated bakery down at the Cape. In just 3 years, tile production at the bakery has surpassed the total number of tiles produced during the 30 years of the shuttle program. To go from the raw material to a finished tile, it takes about 40 hours. And today, the bakery is producing about 1,000 tiles a day. But it's set up to produce enough tiles for 10 ships per month, which is about 7,000 tiles a day, or a tile off the line every 13 seconds. So yeah, the bakery is well on its way to providing Starship with all the tiles for missions to Mars and beyond. And for today's flight, we've made a modification to the heat shield tiles. Dan, do you mind filling us in on what's being referred to as the Crunchwrap tile?
Absolutely. I always love to get to do a little show and tell. So we've got thousands of these heat shield tiles covering Starship. Now they're kind of all next to each other. There's a small gap in between all of them. You got to leave a little bit of space as that metal underneath will expand and contract. That way they don't crunch into each other and start breaking. However, that lets some of that plasma kind of seep through, and we see really high heating on the sides and then down on the metal. To help fix that, we have this, the crunch wrap that everyone has heard about. So we take essentially that's called Vulcan felt that we then wrap around. And so as these tiles are next to each other, you've got a small bit in between that's going to help offset that heating. It's just one of the ways we're continuing to iterate on this heat shield, getting towards rapid reusability. Hopefully it's going to help Starship live Moss. You know, everything is just going to get us to that end state of a fully and rapidly reusable vehicle. So pretty much the entire vehicle has those on it today. We've done this on multiple Starships previously, but this time pretty much the whole vehicle has it. So that was special for today. All right, enough heat shield tiles. Let's go quick check-in on the pad. So if you did notice, we did shift our T0 just a little bit. We're now counting down to 6:23 and 41 seconds Central Time. We shifted a little bit as we were working to finish clearing the range. We are monitoring sea and airspace, both here over the Gulf and in our splashdown location over on the Indian Ocean. We were working with the FAA, a lot of other international agencies to coordinate all of this. Good news, range is currently green. We're able to get everything out of the way that we are tracking in the Gulf. So weather status, I don't even really need to do, not a cloud in the sky, beautiful day, no probability of violation for launch at this point. We're not currently tracking any issues on the vehicle or the pad. You can see our fill levels are getting up there. We're almost completely done with our propellant loading. We've gone through all of our checkouts so far this morning, aligning our guidance, navigation, and control system, getting the vehicles ready for prop load, the farm. Everything has gone pretty smoothly so far. We got through our go, no go for prop load. That happens at T-minus 1 hour and 15 minutes. We've been loading fuel and locks on board the ship since about 53 minutes before launch. Boosters started just about 10 minutes after that. We continue loading prop until just around 3 minutes before liftoff, and then at that point we'll be ready to go. So bottom line at the moment, we're looking real good. Again, 6:23 and 41 seconds Central Time is our target T0, so we're going to keep counting down.
Sounds like great news so far. Thank you, Dan. And we do say it repeatedly because it's important to understand, but these flight tests are all about the data. Data helps us build and fly faster until we're eventually ready to fly people and cargo at scale to Mars. That is our foundational mission and basically just the major inspiration for our work here every day.
Yeah, that's exactly right, Amanda. And our first missions to the Red Planet are just down the road, and we recently shared some exciting news. Starship cargo flights to the Martian surface for research, development, and exploratory missions begin in 2030, and we already have our first customer.
Yeah, exactly. Starship is open for business, and one of the first payloads will be provided by the Italian Space Agency. They recently signed a first-of-its-kind agreement to carry Italian experiments on the initial Starship missions that deliver customer payloads to Mars. In related news, Starship cargo flights to the surface of the Moon for research, development, and exploratory missions will start in 2028. So a ton of Starship activity to look forward to, and if you'd like to learn more about our mission to making humanity multiplanetary, go ahead and visit spacex.com/Mars. Okay, now as we get closer to launch, development continues down here at Starbase, Texas, to shape this growing city into a truly unique place to live and work. And part of being a city, particularly one surrounded by nature, is environmental stewardship. The nearby Boca Beach dunes have unfortunately been eroding at an alarming rate for some time, so SpaceX is teaming up with Cameron County and the city of Starbase to stop that erosion and hopefully preserve the beach for years to come.
Yeah, and as one of its first permanent residents and someone who's actually called Starbase home for over 3 years now, I can tell you the beach totally adds to the uniqueness and awesomeness of living here. Starbase is truly unlike any other place on Earth. You know, where else can you see the world's biggest rocket every single day?
Yeah, Starbase is definitely the place to be, and we're always looking for more people to come help build the future of spaceflight.
Yeah, particularly engineers, especially for our propulsion and mechanical system teams.
You could be working on tests just like these ones, proving out the designs of our next generation Super Heavy booster. Fun fact, we actually tested the booster to 13,400 tons of thrust, which is more than the power of 3.5 Saturn V rockets, which is just crazy. We're also looking for civil and structural engineers to help literally build the future.
Whether it's buildings like the Gigabays currently going up at both Starbase and the Cape, each is a massive vertical integration and assembly facility with over 700,000 square feet of workspace. Both sites are currently in progress, actually going vertical as we speak. Or you could be designing the Starship launch sites of the future. There's really no shortage of future to build here. So visit spacex.com/careers to see all of our openings if you're interested.
Okay, now as we head into terminal count, all eyes are on the rocket. Dan, how are we looking? Are we green?
Amanda, we are so green. Everything's still looking really good. So we've got a green range, not tracking any blockers there to launch. We're continuing to load prop on board the vehicle. We're just about to close out, so we'll close out, again, just about 3 minutes and 20 seconds before liftoff. We'll close out on ship, and then booster just about 30 seconds later. And then you end up with about 11 million pounds of liquid propellant on board those two stages. After we're fully loaded on the vehicle, the pad itself gets ready for launch. We do what's called pushbacks. We clear all that prop out of the lines in the tower and the feed system back into the tanks to get ready for launch. And then in the next couple of minutes, we're going to do our final GNC guidance, navigation, and control system alignment. We're going to arm the automatic flight safety system, and then we're going to do final kind of wiggle checks on the steering for the engines, which we might be able to catch a quick peek at as we get closer to those. If we need to hold, which we are not currently tracking a reason to, that would happen at T-minus 40 seconds. It's built into our countdown. We can pause and wait there for any final checkouts, anything that we need to hold for.
Once we pass that T-minus 40 seconds, a number of events will occur in rapid succession. The ground spin and ignition systems come up to flight pressure, and ship switches to internal power. After that, the quick disconnect arm lockout is removed in preparation for retraction shortly after T0. Now, once we pass T-minus 40 seconds, if any problems come up, we do still have the ability to recycle the count under certain conditions back to T-minus 40 seconds and hold there to assess what happened and then see if we can proceed again to liftoff.
Yep, however, once the water for the deflector system begins flowing at T-minus 10 seconds, any issue after that would be an automatic scrub for the day, as teams would need to refill the deflector's water tanks as well as the propellant storage tanks at the tank farm before making another attempt.
All right, we are coming up on 3 minutes. away from launch. You can see the frost line all the way up. We've just closed out prop load onto the ship. Booster coming up shortly. Yeah, in about 10 seconds we'll finish loading prop on the booster, and then again we'll have about 11 million pounds of that liquid oxygen, liquid methane on board the vehicles. Not currently tracking a reason to hold at T-minus 40. It can pop up at the last moment or after we pass that gate. We can always hang out there for a couple of minutes if we need to. We do have some extra time. We're not constantly topping off the propellant in these vehicles, so we have about a 7-8 minute window where we can wait for any final issues to clear. We're not currently tracking a reason to hold there. Again, our range continues to be green as we look at sea and airspace both out over the Gulf and in our reentry zone out in the Indian Ocean. All right, 2 minutes, 15 seconds to go. A lot of things on tap for Flight 11. Planned to be the last launch of this version of Starship and Super Heavy. Once again, we're really focused on getting ship over to reentry. Once we get to that phase, we're going to dive in. There's a lot of exciting stuff that's going to be happening on our way back through and down to the ground, hopefully out in the Indian Ocean. Minute 45. Should hopefully be seeing... There's a quick wiggle check. Checking out the thrust vector control, the steering on the booster. We use those inner 13 engines. Doing their one final dance before the big show. And we'll do that one more time after we cross that T-minus 40 gate. Alright, range continues to be green. Still not tracking any issues on vehicle or pad. 1 minute to go. As a reminder, we can hold at T-minus 40. We're not planning to. All right. We're through T-minus 40. Let's listen in. Flight Director Ty Huntington back in the seat. Take us through the final
Flight
seconds
directors, go
until
for launch. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have liftoff. Go Super Heavy. Go Starship. Thanks for all the historic flights, Pad 1.
Vehicles pitching downrange. Booster Raptor chamber pressure nominal.
Booster and ship, nominal power and telemetry.
All right, we are about 45 seconds into flight. We're still getting the rattle here at Star Factory. We are seeing 33 out of 33 Raptor engines lit on Super Heavy as it arcs across the Gulf. Coming up next on Max Q.
Max Q.
So at this point, we've passed through that period of maximum aerodynamic pressure. The next thing we're looking forward to is going to be hot staging. So we've got 33 out of 33 Raptors lit. Super Heavy makes its way uphill. Hot staging is going to be coming up in just a little over a minute. At that point, we're going to see all but 3 of those Raptor engines on Super Heavy shut down. Our version of MECO Most engines cut off instead of main engine. And then after that, we're going to release the clamps that are currently holding Starship to that hot stage adapter. It's then going to ignite its 6 Raptor engines to push it away from Super Heavy and then start making its flight uphill. So in about 30 seconds, we're going to see the engines start to shut down on Super Heavy. You'll see them kind of shut off in separate banks until we've just got those 3 center engines that never stop running for this process, and then looking for 6 ship Raptors. All right. Miko coming up in about 10 seconds. See the engines throttling down.
Booster engine cutoff. Ship ignition.
Stage separation.
Use backburn startup.
All right, successful hot staging maneuver. So we've got 12 of the 13 engines lit back up on boosters, so it's doing its boost back. Real excitingly, though, we've got 6 out of 6 Raptors lit on ship there, so it's now going to continue to make its ascent into outer space. Meanwhile, this boost back is happening. We're using those 13 engines, so everything, well, 12 out of the 13, and then we go down to 3, and then we're going to shut down for the end of boost back. That's sending Super Heavy back towards its planned splashdown zone in the Gulf. Right after we finish this boost back burn, we're also going to separate the hot stage. This will be the final time that we're doing this. Is all right, there's the end of the boost back burn. We should be seeing the hot stage. So the hot stage separates. It's going to make its way down, also splash down in the Gulf. In the meantime, though, these 6 ship Raptors are going to continue firing for about 5 more minutes. Next up for the booster, though, is going to be its landing burn. There's a cool tracking shot. We dumped some of the prop out on our way back in. All right, so for booster, this is one of the main things we're trying to get is going to be this landing burn. Oh, that's so you can see the hot stage kind of making its way towards the left side. So that's the bottom of the booster. It's about to pass right in front of where you can see some of that prop dump happening. They look like they're close together, but there's a good amount of distance between them, and the hot stage will go down and splash down in the Gulf while the booster comes back for its landing burn.
Starship is on nominal trajectory.
All right. Looking good on our trajectory, looking good on everything. Jake and Amanda, you guys with me down there?
Yeah, definitely. The crowd is gathering over here in the office. You can definitely feel the energy in here. Great to see that booster is making its way down to the splashdown zone in the Gulf.
Yeah, the shaking down here was absolutely nuts. The windows are still there, still intact. So that was pretty awesome. But yeah, booster's coming down. We're at about 30 kilometers. All right, yeah, and as we approach that landing, just like tower catches, we will be doing a 13-engine landing burn to slow down. This time it will be in a V3 configuration. And as we're starting to get into the denser part of the atmosphere, the booster is using 4 hypersonic grid fins to guide itself through atmospheric entry towards its landing site.
And we're just about 20 seconds away from landing burn start, where we'll first ignite the center 13 engines, then bring that down to 5 to slow down the booster for landing. And finally, that will come down to 3, and we'll cut all of them off while we're still about 200 meters in the air. So booster is going to see a bit of a harder thing.
Booster landing burn startup. Booster landing burn shutdown.
And there we heard it, booster landing burn shutdown. We saw a 13 to 5 to 3 V3 demonstration, and into the water we go. Wow, that was absolutely awesome. If you can even hear us right now, congrats to the whole SpaceX team. So far, so good for today. That was incredible.
All right, great stuff, guys. I'm jealous of the crowd. All right, back to ship. Ship's still making its way. We've got a little under 2 minutes left in this ascent burn, so we've got all 6 Raptor engines still firing. So the next major milestone we're going to be looking for is SECO. That's our second stage engine cutoff. That's should be coming right at about 8 minutes and 58 seconds into flight, so we've got about 1:20 still to go. Really cool to see Booster go through that landing burn. That was one of our really key demonstrations we wanted to try and do today. That's mimicking what we're going to be hopefully doing. Oh, we just got our sonic boom, sounds like, from the booster coming back. All right, less than a minute to go. So we are going to see the 3 RVACs, the vacuum optimized engines, shut down first, and then we'll shut down those 3 center engines. So we should be a little under a minute until SECO. Just a reminder, this is putting us into a suborbital trajectory, so we're intentionally just going slow enough that we're not going to achieve full orbit. This puts us on a course where those engines shut off, and no matter what, we're coming back.
Starship is in terminal guidance.
In the Indian Ocean. All right, terminal guidance. So we should start seeing the shutdowns come up in just a couple seconds. Less than 30 seconds to go in this ship ascent burn. All right, RVACs have shut off. 3 more to go.
Ship engine cutoff.
All right, all ship Raptors have shut down.
Nominal orbit insertion.
You just heard nominal orbital insertion, so we are on the path that we wanted to be. So we've got a ship back in space, a whole lot planned for it, lots more still to come. Great seeing Super Heavy make its way to the water, but I'm excited to see what ship can do in space. How's everybody doing down there?
Yeah, if you could hear the crowd behind us this whole time, people are definitely happy with how the day's been panning out so far. Definitely exciting to see Starship safely in space, and super pumped to see all the team's hard work in action here today.
Yeah, and we guaranteed it at the start of the show, but it has been an awesome day so far. It's crazy. All this has happened in just 10 minutes. All the objectives were met on the booster, including that V3 style landing burn. So now all eyes are on the ship as we get ready for our in-space objectives. But we've got a few minutes until that next milestone, so sit tight, enjoy the views, enjoy the space jams. We'll be back at T plus 16 minutes for payload deploy.
All right, welcome back, everybody. If you're just now joining us, where the heck were you? But we are getting ready for payload deploy. That's going to start once we get the payload door open. That should be happening, or at least starting, within the next minute or so. It's been a really cool flight so far. Quick look inside the payload. We've got 8 Starlink simulators getting ready to make their way into outer space. But great flight so far. Booster able to make it all the way to its splashdown and landing burn experiment, so that was really exciting to see. We got ship on orbit, nominal orbital insertion, so right on the money with its trajectory. Now we're ready to start tackling a couple of in-space objectives. So next up, we are currently venting down the nose cone, essentially the payload area of Starship, as we get ready to open up this payload door. We were able to do this successfully for the very first time on our last flight, on Flight 10. Oop. Hal got ahead of me. Looks like he's opening up the payload door already. All right, looks like we got the door open. All right, so payload door is open. Next up, gonna be to start deploying these Starlink simulators. They are roughly the same size as the V2 Starlink satellites that Starship's going to be carrying. That's going to add some pretty crazy capacity. We'll run through the numbers in a little bit. We were able to do this for the very first time ever on our last flight, and so this will be another test. We made a couple of tweaks to the rails for deploying this based off of what we saw last time, but excited to see these get out the door. Our next iteration of Starship's also going to have kind of a more powerful PEZ. It's going to deploy these at a little bit faster speed, but looking to see our next demonstration of this hopefully in the next couple of seconds. We should start seeing them move out the door. I mean, that view on your left, so you're basically, that would be if you were sitting at the very top of the nose cone looking down. So there's kind of a short stack. There's 4 on either side, so 8 total. When we start flying Starlinks, for their actual deploy missions, we're going to be carrying stacks of about 60. So much larger stack once we start flying these operationally, but still doing a little bit of a short just for this payload deployed today.
Looks like we got a little bit of movement there, Dan.
Coax it out. Get it moving, Jake.
There we go. All right, first one going out. All right, first one's deployed. Getting ready for the second one here. We do a little reset back to the center position.
Yeah, it takes about a minute for each one.
Looks real smooth too. They made a couple of tweaks to those rails. If you watched the last ones, it had a couple of bumps on the way out, but moving out super clean this time.
Yeah, and as noted earlier in the show, but definitely worth repeating, Starship will deploy Starlink's more advanced V2 satellites, adding 60 terabits per second of capacity to the network per launch. So that's 20 times more than each Falcon 9 launch does today. Just incredible.
Yeah, and anybody that's been following Starship, you know, Starlink's kind of the MVP for these flight tests, where it's not only giving us the views we're seeing right now, but also just real-time data through every phase of flight. So We've got a couple dozen cameras on Starship. We've also got a bunch of cameras spread across the globe, including out in the Indian Ocean where we've got our fun buoys floating. There goes another one. And I mean, we're using Starlink to bring all of this together. It's our drone shots you see here from our great team down here at Starbase, all connected. So Starlink not only giving us cool views off the planet, but also on the planet, help bring everybody along for all these Starship flights. I think that's number 4. Somebody check my math. Okay, we've got 4 Starlink terminals on the outside of Starship. It uses that to talk to the constellation. And through that, we actually get about 120 megabits of bandwidth for our downlink. That's our real-time HD video, all of our telemetry. So it's not just kind of giving us these cool views inside, but it's giving all that engineering data in real time, including re-entry when normally a plasma layer builds up and blocks you out. Starlink, powerful enough of a frequency that we're able to kind of punch through that and still get that live view. All right, next one out the door. There we go.
All right, yeah, Starlink is the world's largest satellite constellation operating in low Earth orbit to deliver high-speed, low-latency broadband internet. This provides internet access to people around the world, many of who have never had connectivity before. Oh. Right. Today, Starlink serves more than 150 countries, territories, and other markets with over 7 million active customers and counting. To meet the global growing demand for high-speed internet, SpaceX expanded its factory over in Bastrop, Texas, which is just outside of Austin, and also introduced Starlink Mini, as well as an upgraded version of the Starlink Standard Kit.
Yeah, and one thing to note about this satellite deploy is that they will be following the same suborbital trajectory of the ship. So these dummy sats will not be going in orbit. We do expect them to burn up on re-entry.
All right, couple more to go. I promise one of these days we'll deploy in daylight. But we're basically trading deploy in the dark so we get those re-entry views for the daytime. All right, I think we got one more to go.
All right, now with payload deploy complete, Starship will now close its payload door and continue to coast around Earth to the Indian Ocean. We still have a ton of major events to come today, including Raptor relight at about T plus 37 minutes. That will be followed by atmospheric reentry and splashdown. So with that, we're going to go on another quick coast.
Yeah, if you can hear us.
right, with that payload door closed, we're going to sit tight, enjoy the views, and enjoy the space jams. Again, we'll be back in just a few minutes for Raptor relight, and then head back for reentry. All right, welcome back, everyone. If you're just joining us, you did miss some exciting stuff because Starship successfully deployed its second ever payload, 8 Starlink simulator satellites. And now we're expecting the relight of a single sea-level Raptor engine in space coming up here just after T plus 37 minutes. So about a minute left to go.
Yep, just a little while. I think we're tracking to 37 in around 49 seconds or so. So we should be just about a minute and a half where, again, as Amanda just said, we're going to relight one of those center engines. This will be the third time that we've tried this. We did it successfully back on Flight 10, and then we did it for the very first time back on Flight 6. This is not a deorbit burn. This is demonstrating essentially all of the systems you would need to do a deorbit burn. So that's obviously your Raptor engine, and then also your header tanks, your smaller tanks in the nose cone, where we have liquid oxygen, liquid methane in a smaller, more easily pressurized container, which we can use for on-orbit burns. And we're also going to tap into those when we do our landing burn. So this will be a critical capability. Once we go to full orbital missions, you'll have to do a deorbit burn to break out of orbit, send it back down to Earth. But in this instance, we're already on our way back down towards Earth. So this is just going to demonstrate the capability of turning one of these engines on. We should be coming up in just about 20 seconds or so, looking for one of those Raptor engines to turn back on. They've been off since we completed that successful Ascent burn almost 30 minutes ago. Here we go.
Oh, Raptor ignition. And shutdown.
All right, there was that Raptor relight. Looks like engine 3, full duration. As Dan mentioned, that's a third attempt, and we just did it 3 times in a row. So congrats to the team, the ship team, Raptor team. And then there we heard nominal second orbital insertion. All right, so congrats everyone on the milestone. That was awesome to see. We're 3 for 3. We're gonna take another break, and we'll be back for re-entry at about T plus 45 minutes. We'll see you soon.
Starship is slewing for entry. Starship is approaching entry interface.
Ship is starting entry, good attitude.
All right, welcome back, everyone. The ship is currently re-entering Earth's atmosphere. As a reminder, we don't plan to recover the spacecraft today, but rapid and reliable reusability is the ultimate goal.
Yeah, the light show has already begun. You can see plasma starting to build on the windward side of the rocket there. And, re-entry is a critical phase of flight, and we need information on how the ship systems perform. Re-entry is also extremely demanding portion of flight because we need the ship to scrub off all of the energy we used to launch the rocket. So remember the 33 engines plus the 6 engines on ship that we used to get up into space, we now are using aerobraking essentially to scrub off all that energy. And of course, Starlink is a big part of this, giving us the views we have right now, and also letting us gather as much data as possible, which again is really the main reason why we do these flights. And the view we have right now is actually a really good example. As we mentioned at the beginning of the broadcast, we have some tiles on the leeward side of the flaps here, and we have some different mechanisms, some stud out, basically to see if these tiles will hang on. And we can see already here, it looks like we kept most of them, but I think I see a couple there that are no longer there, so the thermal team is definitely going to be digging into that and taking that data to help us iterate on V3. So yeah, Starlink provides us with one more path to collect data and help us rapidly iterate Starship's design.
And if the ship does manage to make it all the way to re-entry, we'll collect valuable data on the spacecraft flying through the Earth's atmosphere at hypersonic speeds, or more than 5 times the speed of sound. Re-entry is typically a portion of flight where we don't have communications with spacecraft because it's re-entering at or around orbital velocity, which is roughly 8 kilometers per second or 5 miles per second. At those insanely high speeds, the spacecraft moving through the atmosphere creates a plasma field around the vehicle.
Yeah, and that blanket of plasma distorts communication frequencies, so it's not uncommon to experience brief blackouts in communication. All right, so big picture here, Starship is designed to land on Mars where there are no runways or other humans to help out. So that means we need to do a propulsive landing instead of a more traditional means like parachutes, which is what our Dragon spacecraft uses, or a runway like the Space Shuttle. Propulsive landing enables more rapid reusability.
Now, as the ship makes its way back to Earth, we should start hearing some callouts when we hear entry max heating and entry max Q. That means the ship has made it through the maximum heating and aerodynamic loads it will experience as it returns. So if it makes it through all of those, that's a pretty good sign that we're doing well.
Yeah, and we heard flaps have control of the vehicle now. Okay, there's a great shot there. You're starting to see the plasma build up. So we will hear a call out when the ship is transonic and then subsonic. Transonic refers to the period of flight where the velocities of airflow surrounding and flowing past the vehicle are concurrently below, at, and above the speed of sound, somewhere in the range of Mach 0.8 to 1.2. All right, a lot of numbers coming up here, but for reference, commercial jets have a range of cruising speeds, but most fly around Mach 0.74 to Mach 0.85, which is 480 to 575 miles per hour, or 770 to 930 kilometers per hour. Right now, we're going a little over 26,000 kilometers per hour. So compare that to the airplane at 930. It's like pretty crazy how fast we're going here. All right, and after we hear the call out that Starship is transonic, we should hear the call out that Starship is subsonic. Subsonic, of course, refers to the speed that is much less than the speed of sound. So at that point, the ship's velocity will be starting to slow down, and we'll be looking a little bit more like some of our suborbital flights from, at this point, almost 5 years ago.
Yeah, so re-entry so far is looking pretty good. You can see that plasma field. Also, again, with those missing tile experiments, especially, we're putting the ship through a lot today, but things are looking pretty good so far.
Yeah, we're looking good. I do want to remind people that we are pushing ship to the limits. We've done a lot of these missing tile tests. We did it back on Flight 10. Every time we do it, we throw something new and the ship makes it through. This time, we're really pushing it. We've removed these tiles in some of the spots that see the highest level of heating. And we remove tiles that have zero backup protection underneath. So there's essentially just bare steel. It's one of the heat of re-entry. And so do not be surprised if this is not a very smooth flight on the way down. But again, this is intentional. We are trying to find what are the limits for a ship. How resilient are we to these different issues that could pop up? If we lose a tile anywhere in the vehicle, we want to know what that ultimate impact is going to be. So we've got a couple missing. We had a bunch pulled over the primary fuel, the LOX tanks, everything. This one, we've got a tile missing right on top. So that's going to see some of the highest temperatures during this re-entry, and there's just bare steel right underneath it. So we're going to see if Starship's robust enough to pull through that. Also have some tiles missing around the aft flaps, specifically on the leading edge. So again, we're getting a really good look right at the leading edge. That's getting really intense heating. So again, gonna see if it can make it through. See if all the flaps hold on, see if Starship holds together. But definitely could be a bumpy ride, but this is why we're flying. This is why we're flying in this part of the world. This is why we're putting Starship through these flight tests to really understand what its limits are. So we can then move on to the next thing, which is going to be bringing ships back to the launch site for a catch. But for now, still on this suborbital, the light show continuing. Keep following it in. I think we got about 15 minutes until splashdown.
Yeah, Dan, it looks, you can see our speed our speed indicator in the bottom left there. It looks like we're starting to scrub off velocity a little bit quicker.
Ship is entering the peak heating phase of flight.
Looks like we can see some clouds down there as we pass through 70 kilometers altitude.
Yeah, the sun's starting to come up again. Ooh, there we go.
There we go.
Skirt is intact so far this time. If you watched Flight 10, you saw we entered with a little bit missing. That was ultimately traced to a little bit of buildup. We dumped prop on the way. We had a little bit of solid propellant buildup, and then either static discharge or the plasma ignited it, took out a tiny bit of that skirt, some of the aft flaps, but Starship, again, was able to fight through it, make it all the way to that landing burn. We addressed that, changed some of our prop dump con-ups, though, so should not be seeing that this time around. And as a reminder, in addition to these missing tile tests, we're doing kind of a unique flight on the way in. It's going to do what we call a banking maneuver. So while we're still going supersonic and even hypersonic, we're doing kind of a banking turn. And then we'll do a pretty aggressive turn right as we get into the subsonic and start doing our belly flop. And that's designed to essentially be the approach that we would do on a return to launch site and a tower catch. So don't be surprised if we see the ship start to turn and make a few maneuvers as it makes its way down to the Indian. And fun fact, even though we're doing all this turning, we're essentially targeting the exact same spot in the Indian Ocean we went to last time. All right, just about 12 minutes to go. Still looking good. That gives a pretty good view of those aft flaps where, again, on the leading edge, I think it might be on the one on the other side, we had some tiles removed with no backups behind it. So again, we're really trying to stress some of the most sensitive areas around Starship, where basically if you lose a tile, it's the worst possible spot. And if we're able to make it through this, then that tells us quite a bit about just how resilient this vehicle is.
Yeah, and that shot we just had earlier was looking at what we call the business end of Starship with all the Raptor engines. And those are the engines that we're going to be expecting to light for that flip and landing burn, hopefully in about 10 minutes once we get through reentry. Yeah, there we go.
Yeah, looking at E3, that's the one we did the relight on. So it's 2 for 2 so far. We'll see if it can go 3 for 3.
Yeah.
All right, we can see that speed just continue to bleed off under 20,000 kilometers an hour. Ship's still holding together.
Yeah, and if you look in the bottom right, looks like we've made it all the way to the Indian Ocean. We're coming up kind of near Australia, the west side of Australia there, so pretty crazy. We're only 56 minutes in, and we've made it all the way, halfway around the world. It's actually a good demonstration of a future capability we hope to have on Starship, where we will do point-to-point transport on Earth. So essentially travel anywhere in the world in about an hour or so, which is going to be pretty crazy. Imagine going from New York to Sydney in 1 hour instead of the 20 hours it takes currently.
And a reminder, so this camera is, we see some of the heat rate picking up a little bit. And this camera is embedded right in the end of one of those forward flaps, so you see it moving around. That's the flap adjusting to maintain control. Looks like we're getting into our bank maneuver. Now power sliding through the atmosphere.
External temperatures are coming down. Vehicle is now at maximum dynamic pressure.
All right, that was basically our reverse max Q, so most aerodynamic stress that it's going to see during reentry, we just passed through it. So we're past that, we're past peak heating. Ship's still holding together. So we're currently in this bank maneuver. We're gonna see it kind of roll over and do a pretty significant shift as we get down closer to the subsonic speeds.
Yeah, and that bank maneuver that Dan's mentioning is all in part of us to learn about the guidance, navigation, and control for return to launch site missions. So in the near future, we're hoping to return the ship back to the same pad we just took off on 59 minutes ago, and we've got to do some of these pretty dynamic bankings to make that trajectory work out.
All right, the light show kind of calming down as we're starting to move into the lower parts of the atmosphere. We should hit transonic, so hitting that transition between moving faster than the speed of sound and below the speed of sound in just about 3.5 minutes. Our landing burn should happen right around an hour and 6 minutes after launch, so we should be just about 6 minutes away from that. You can see lots of daylight. Everybody cross your fingers, see if our range team was able to get out there and provide any surprise views as Starship makes its way down. Oh, it's like they heard me. Ready and waiting, let's go.
Dan, you just spoke that view into existence there. And again, all brought to us by Starlink.
Maneuver has started.
All right, there we go. So we're now starting into our really heavy bank maneuver. Again, this does almost like a half circle loop to our actual trajectory. We're heading to the same exact splashdown point, but we're kind of doing a more roundabout way to get there, where it's this kind of big, long half moon loop and then a really aggressive and a twist right at the very end, and that would line us up with the launch tower. Starship, on a return to launch site, would fly over the tower, do a quick landing burn flip, and then come down for catching the arms.
How about that S38 decal there, staying strong on that view we just had?
Good to see the numbers back on.
Yeah.
All right, should be hitting transonic in about 2.5 minutes. Landing flip coming up in about 4. Pretty clouds there in the Indian Ocean today. Again, yeah, we changed our launch times. We launch in the evening now, so we get these daytime views down in the Indian Ocean. One of the things we're really looking for, the reason we have the drone, other than, yeah, that looks really cool, is we're able to kind of see the ship. We can only see so much from these cameras. You can't see like the vast majority of the heat shield. So we throw these buoys out there. We've got there's...
You spoke it again, Dan. There it is.
They're playing with me in the control room. All right. But we have these buoys out there. We have these drones that we're trying to see externally how the heat shield held up. Everybody saw from Flight 10 it had a little bit of a paint job, a little bit of a reddish hue. That was from those metallic tiles that we had tested, kind of oxidizing really rapidly in that plasma and then spreading those little oxide particles all over the heat shield. No metal tiles on this flight, so not expecting to see that.
Dynamic pressure is coming down.
Hope nobody gets seasick. All right, coming up on transonic shortly. It's about 2.5 minutes of landing burn.
Yeah, and once we get to around the 15-kilometer altitude mark, that's where we have a lot of flight history.
Starship is transonic, starting the belly flop phase of flight.
Yep, that belly flop phase that we perfected in the suborbital campaigns, we're entering that now.
Right, starting to get those Raptors ready. Should be 2 minutes away from landing burn. Again, we're going to do a flip. After we ignite those engines, we'll go from 3 down to 2 for the final phase of the landing burn and look for another soft splashdown, hopefully by our buoy and drone, which are hanging out, ready and waiting for a ship.
Seeing all 3 center engines have entered the chill phase.
All right, less than a minute to go.
The ship is making its turn for final approach.
And here's this kind of aggressive final turn that would essentially position it so it's right behind the launch and catch tower. Flaps holding strong. Landing burn in just under 20 seconds.
Ship landing startup.
There's our landing burn. Three down to 2.
Starship has landed.
As we said, we're not planning on recovering the ship today. Hey, welcome back to Earth, Starship. We are down in the Indian Ocean. Let him hear it, Starbase. What a day.
What a flight.
Oh. All right. welcome back to Earth ship. What a day. A whole lot more to go through. As you just saw, everybody here at Starbase pretty hyped. Hey, Tyler, out of Hawthorne, how's everybody holding up?
Thank you, Dan. We had a fantastic time watching. It was another exciting Starship flight test in the books, and we hope that you enjoyed those Starlink views too. So congratulations to the team at Starbase and everyone here and around the company. So many employees contribute to the Starship program as we continue to iterate and make progress towards a multi-planetary future. So that wraps it up for us here in Hawthorne. Thank you for tuning in, and back to you guys.
Yeah, what an incredible launch today. We had successful liftoff. Booster completed its objective, successfully splashed down over in the Gulf. Obviously, we saw another amazing Starlink deploy as well from ship.
Yeah, we made it through that re-entry, testing all the different experience. We had missing tiles, gave us quite the light show. We had that Raptor relight 3 for 3. That was ahead of re-entry, of course. And then that awesome splashdown that we just saw, including that dynamic banking maneuver to simulate RTLS when we returned to the launch site. So yeah, we promised maximum excitement, and Starship delivered.
Definitely.
Congrats to all our teammates at SpaceX and to everyone who's supporting the Starship program. And thank you to all our future customers for your support.
We'd also like to thank the fine people of Cameron County, including the residents of its newest city, Starbase, as well as the Coast Guard, the Federal Aviation Administration, the Government of Mexico, and the Australian Space Agency.
Yeah, be sure to follow SpaceX on X for updates and about more of the exciting views we didn't get to feature on today's broadcast.
And if you're interested in more launch coverage just like this, head over to spacex.com/launches for the most up-to-date information.
All right, I will take us out. Hey, congrats, Jake and Amanda. You guys did amazing. Great job. All right, today we launched the world's biggest rocket, knocked out all of our objectives. Shout outs to every single person who made this look easy. Thank you to everybody tuning in. We're going to see you back here for the very first flight of our next generation Starship. So we'll see you then. Good night.